Good morning. We see another type of different type of problem in pentagonal lamina. So you can see in this question a pentagonal lamina of dimension 25 is having a side both on HP and VP. Okay, we have to make sure that one of the side has to touch both the HP plane and VP plane. Okay, so that's what the condition. The corner opposite to the side on which it rests is 15 mm above HP. That means it is indicating the second position. So drawing a 15 mm line and drawing the locus, so you can construct the second position. So you can see in this question they are mentioning we have to make sure that one of the edge has to be there in the HP plane and one of the edge has to be there in the VP plane. So you can see with respect to the condition I have drawn the edge AB, it is resting on the HP plane. Okay, and second angle of inclination is there with respect to 15 mm above HP. Now the third position we have to go with this condition. A side has to be there on both on HP and VP. Now the side AB, it is already there in the HP plane. We have to make sure this AB plane has to be there in VP. How to do that? We will take this AB edge and has to touch the XY line. By touching this AB edge, touching the XY line, we are making sure this AB edge, it is touching the VP plane. Okay. First I will take a reference point of B here. From B to A. So this is the length. So we have to transfer this diagram with respect to BA. These two lengths will be same. Okay. Now reverse it is. Okay, so reverse we have to touch it. So after this we have to transfer the diagram measuring this length E to D. So this length is exactly equal to okay. So this is C, this is D, and this is E. So join all these points. Okay. So now projecting upward, we can complete the rest of the diagram. So we have B dash and A dash here. Okay. And similarly we have this is C dash, this is E dash, and this point is D dash. So these are we complete the problem. You can see that we have to make sure the side both on HP and HP VP means the side it is there in the HP plane. Okay, now we are making it touching the VP plane. Okay. We see a different type of problem in hexagonal lamina. We see in this problem we have to construct a hexagonal lamina of dimension 30 is resting on HP with one of its corners in VP. Okay, it will be a different type. And the surface inclined at an angle of 30 degree to VP. The diagonal, okay, the diagonal passing through the corner which is in VP, appears to be. They have mentioned appears to be. So means means no beta angle. Okay, and then they have mentioned inclined at 40 degree to HP. So in this problem you may be coming across, so it is resting on the HP plane with corner. So we see with the trials here, the trial 1, just a rough sketch XY. Say it is resting like this, first position. Okay, first position, inclination to HP given 40 degree, and here we get another diagram here like this. Okay, so this is the diagonal, but you can see in this question the diagonal passing through that corner which is in VP. So this is our diagonal. So this diagonal, it is there in the HP plane. Okay, so with the question it is telling which is in, okay, the diagonal passing through that corner which is in VP. So that means this diagonal has to be there in the VP plane. That means this triangle, this trial, it is wrong. Okay, so this trial you can see that. So in this problem we run the first trial, so resting on the HP plane, corner touching the VP. So inclination we have mentioned. Now with the second condition, the diagonal passing through that corner which is in VP. So this diagonal, it is not there in the VP, it is there in the HP. So that's why this trial it is wrong. Now we see the trial 2. So in this trial 2 we are going to construct like this, on edge touching the HP plane, corner it is in the VP plane, the first position. Okay, and then inclination, it is inclination to VP given. So you get it like this. Okay, second inclination, and third inclination, you can see this is what our diagonal. So you can see here diagonal, it is there in, is in VP. So this trial it is correct. So we will proceed now with the solution. Okay, so we have to get the hexagon here, hexagon of dimension much 30. So I'm going with another method, that is measuring 30 mm and drawing a circle, so it will become easy to construct it. So drawing a circle here, okay, so herein we have to construct like this, right? So for that I'll be drawing like this, initially 30 mm line edge, okay, edge with the dimension 30, and then measuring for 60, angle method only will do it. Okay, so 60, marking the angle and drawing a line. Similarly here also we will do with the same procedure. Here 60 in this direction. Okay, now we have to cut it at 30 here, right? 30 mm. Okay, so we have 130. Now again to this point, we have to merge this line. Okay, again we have to mark at 60. Okay, so again 60. So already we have measured at 30. So I'm cutting the arc. So now we have to join it. Okay. So this is what A dash, B dash, C dash, D dash, E dash, and F dash. So it is having a dimension of how much? So 30 it is. Okay. So the top we get it here on this line, on the XY line. Okay. So this is B, C, F, A, D, F, F, E, right? So the second angle of inclination, that is inclination to VP, they have mentioned 30 degree. First I will mark a reference point here. So to this reference point we are taking an angle of 30 degree. Okay, now we have to cut the arc from B to E. Okay, from B to E we have to cut the arc. So this is B and this is E. The another arc we have to cut from B to D, second arc, third arc from B to C. Okay, so this is C of E, this is D of S, is 30 degree, right? So we are going to dark this length. This is what the thing which is important. So now we will project it upward to construct the second position front view. So here we get here B dash, and here at this point we have A dash. Okay, and this is we have F dash, this is F E dash, this is D dash, and this is C dash. So we have to join this. Okay, now you see the question, we have to take the diagonal passing through that corner which is in VP. So this is what the diagonal which is there in the VP, right? So this is the diagonal in VP. So we have to incline at an angle of 40 degree to HP. So what we do, so here it appears to be no bit angle. So we'll take a reference point. Okay, and the angle of inclination we take here is 40 degree. So 40 degree we have taken. Okay, so now we have to take this B dash. Okay, so we have to place it with respect to the diagonal. B dash, B dash, B dash, B dash, B dash, E dash we have put it. Now from There are two arcs we have to cut, then another two arcs here. Okay, so now it is reverse. So now it is cutting here. So now we have to join this. Okay, this is C dash, D dash, C A dash, F dash. Now projecting downward, so we can complete the final position here. Okay, so we get B here. Okay, so we get C here, and we are getting D point here, and we are getting E here. This is F. Okay, so the A point we are getting here. Okay, so we have to join this. So this is how we complete the problem. Good morning. We see a different type of problem in hexagonal lamina. You see the question. So we have to construct a hexagonal lamina for dimension 30 mm, lying in such a way that one of its sides touches both the reference planes. So it is somewhat like a similar pentagonal lamina problem in which one of the side has to touch both HP plane and VP plane. That's what. That says that one of its side touches both the reference planes. The side opposite to the side, if the side opposite to the side on which it rests is 45 mm above HP. So you can see that this is what the side which is opposite to this side, it has been inclined at a height of 45 mm. Okay, so that's how we get the second position here. They have not mentioned any kind of inclination here. Instead of it, for the second position they have mentioned this sentence, that is side opposite to the side on which it rests is 45 mm above HP. So what we do after completing the first position, we draw 45 mm line and draw the locus. Okay, after that I'll be making a reference point. Okay, then measuring the length from B dash D dash, I'm cutting the arc. Okay, then after cutting the arc I will be joining a line here. Okay, after that I'll be measuring again from B dash to C dash and then cutting the arc on this line. So this is how we draw this second position. Now you can see in the third position we have to make sure says that the side should touches both the reference planes. Both the reference plane means both HP and VP. Now it is there in the HP plane. What we do that, we will take this AB end and we will make touch the XY line, thereby making touching the VP plane. Okay. So for that I will be taking a reference point of here B. So B to A. Okay. B to A it is. Now cutting the arc length from A to F. So these two lengths will be same. Okay. Okay, now it is reverse. A to C. So here we have to cut. So we are not cutting, so we'll measure again. A to F. So it is cutting here, it's cutting here. Okay, we're getting 2 points here. This point is C and this point is F. Again from F to E, we have to measure this point. F2E is over. Now reverse it is from F to D. Okay. So this point is D and this point is E. This it is touching at this point. Okay. So now you see that this is the A and AB, which is touching both the HP plane and the VB plane. Now we'll project upward to complete the final position. Okay. So here this is B dash, A dash, C dash, F dash, D dash, E dash. So you can join it. Okay, so this is what completes the problem.